Alright? So, example number 3. So, dito, gagawin natin, magde-design na tayo ng spacing of stirrups all throughout the beam. Okay? So, basahin ko muna yung problem natin. So, a simply supported rectangular beam, 350 mm wide, having an effective depth of 500 mm, carries a total factored load of 100 kN per meter load on a 7-meter clear span. Okay, if F prime C is equal to 21 megapascal and FYT is equal to 175 megapascal, design the spacing of stirrup using 10 mm diameter stirrup. Okay? Okay, so ito yung figure natin. So 7 mm yung clear spacing natin. And then we have 350 and then 500. Right? So first, dito, we need to get the reaction first here, no? Yes, okay, so I'm going to draw the figure ulit dito, FBD. This time, lagay na natin yung magnitude ng load natin. Okay, so that is WU, sabi niya dito, factored load. Okay, so ibig sabihin, no need for us to multiply it by 1.2 or 1.6. So therefore, automatic na po na 100 ang ilalagay natin dito kasi factored na yan. Okay? So 7 meters to. So we need to get the reaction here. So ang reaction natin is 100 times 7 divided by 2. Right? So ito, this is R1 and this is R2. Okay, our reaction 1 is equal to R2, which is equal to the W L over 2. Okay, that's equal to 100 times 7 divided by 2. Okay, of course, that's equal to 350 kilonewton. Okay, ito po yan, 350 kilonewton. Both reaction. Okay? So next, dito, mag-focus lang tayo sa isang side. Okay, mag-focus lang tayo sa isang side. Kasi dito, sa ating figure, symmetrical naman siya. So kung ano yung design natin sa left part, okay, in this part, will be also the same dun sa right part. So, drawing ko muna dito yung left part natin. Okay. So, we have here, ito yung center line. Drawing ko na. This is the center line or mid-span. So, ito yung sa reaction natin. So, we have here, kung ano yung value ng reaction natin, ito yung magiging value ng shear natin sa mismong reaction. So, we have here 350. Okay, so 350. But, as the code says, pwede natin kunin dito sa part na to. Yung ating maximum or the shear at the critical section. So, ito is 500 millimeter from the face of the support. So, that's 0.5. Okay, so 0.5. So, andito na po yung ating VU. Okay, yung at critical section. Okay, so we can get that by similar triangle. By similar triangle. We will get the VU 350 is to 3.5. Okay, kalahati nung ano natin. span natin. So, this is 3.5 meters. Okay? This is equal to VU is to this length. So, that is 3.5 minus 0.5. That is 3. So, we will get the value of our VU here. Okay? So, that is 350 times 3 divided by 3.5. We will have 300. Okay? So, we will have here 300 as your VU at critical section. Okay? This is the shear at critical section. Right? So next is next po na gagawin natin is resolve for the VC. Okay? Resolve muna natin lahat nung uh, constant no na value natin like the VC and then all the values that uh, pinampa-check out tawag doon mga limitation natin no mga design limitation natin. So we need to solve that no. So unang-una VC muna tayo. So solve for VC. That is 1 half, 1 over 6. Sorry, so lambda, square root of f prime c, VW, d. So, kahit di natin ilagay yung lambda, wala naman sinasabi na uh, kung anong type of concrete, no? So, automatic 1 na to. So, we will have a VC of 1 over 6 uh, square root of 21 times 300 times 500. 350. Okay, 350 times 500. So that is 1 over 6 times square root of 21 times 350 times 500. Okay, so we will have the value of, so divide this by 1,000, always class, no? Para maging kilonewton agad. So we have 133.66. Okay, kilonewton for our VC. Right? So next is PVC. Ano natin yan? PVC. That is 0.75 times 133.66. Right, so 133.66 times 0.75, we will have 100.25. So 100.25 kilonewton. Okay, so next is 1 half PVC. So kailangan kasi natin to klasa. Okay, kasi all throughout the beam yung kino-compute natin. So talagang magkakaroon po tayo ng value ng VU which is less than this. Okay? So, we need to check pa rin parati, no? Kapag ka nagpo-fall siya dito, doon sa minimum spacing natin. So, that is 0.5 times yung 100.25 or 1 half ng 100.25. That is 50.125. So, 50.125. Alright? So, next na kailangan natin i-check is your what do you call that? The cross-sectional dimension. So, sa cross-sectional dimension natin, the VU must satisfy this, no? This equation, VC plus 2/3 of square root of F prime C, BWD. Okay? That must satisfy niya to. Okay, so we need to get this value first. That is 0.75 quantity 133.66 as our VC plus 2/3 of square root of 21 times 350 times 500 as our D. Okay? Yan. So ito, huwag nyo kalimutan divide ng 1,000. Okay, so ano yung magiging value nito? 0.75. So 501.22 hours as our value for this cross-sectional dimension checking. So meron tayong value na equal to 501.22 kilonewton. Okay, as you can see sa ating diagram, ang pinaka-critical naman na dito or pinakamataas na value ng ating shear is sa mismong malapit sa ah, support or at the critical section. Yung VU natin dyan is 300. So as you can see, dito ang VU natin is 300, no? So 300 which is less than this 501.22. So yung ating dimension is okay. Okay, so adequate na yun. No need to adjust. Okay? So, baka may magtanong, sir, kailangan ba natin i-check parati ito? Okay, dito sa ating example, hindi na. Kasi, na-check na natin sa pinaka-maximum. As you can see, sa shear diagram natin class, it is decreasing. No? So, decreasing. Wala lang tataas sa 300. Okay? Na critical shear natin. So, therefore, kung pumasa na sa at critical section, automatic, papasa na po siya sa mga susunod na shear value natin. Okay? So, okay na to. So, next is, para dun sa maximum spacing natin, kailangan natin kunin yung value ng 1/3 okay, square root of f prime c bwd. Ano kaya magiging value nito? Compute natin. So, 1/3 times square root of 21 times bw, that is 350 times 500. Then, divide natin ng 1,000. Okay? So, 1/3, lagay ko na lang dito. Square root of 21 times 350 okay, times 500. Divide po natin siya ng 1,000. Okay? So, divide natin ng 1,000 to. So, we will get an answer 267. Yan, 267.31 or 32 kilonewton. Yan. Ito na yung magiging pang-check natin mamaya. Okay? Or not checking, pang-identify natin kung anong S-max ang gagamitin natin. Right? So, balik tayo dito sa figure. Okay, sa figure natin, as you can see, ito sa shear diagram, okay, at certain point dito sa shear natin, magkakaroon yung value, yung VU natin will have the same value as the VC. Okay, at a certain point dito sa ating diagram. So, let's say at x1, okay, from the face of the support, magkakaroon tayo ng value of our shear that's equal to the phi VC. Tama? And then a certain point then where our shear will have the same value as that of the 1/2 phi VC. Okay? So, x1 for the phi VC and x2 for the 1/2 phi VC. So, as you can see, itong zone na to, so this zone here, okay, dito is yung papasok yung minimum shear spacing natin. Okay, ito, di ba? When your VU is between phi VC and 1/2 phi VC, papasok dito yung minimum zone, no? Minimum spacing zone dito. Okay? And then this zone here, okay, mas yung value ng shear natin is mababa sa 1/2 phi VC, ito na yung zone where we don't need to put stirrup. Okay? No stirrup zone ito. No stirrup. No need for stirrup sa zone na to. Tama? Okay. So, we need first to solve what is x1 here and x2. Okay? Para malaman natin kung nasa minimum zone na ba tayo or nasa no stirrup zone na tayo. Okay? So, first, we solve for x1. May similar triangle. Okay, so ang x1 natin, ang shear doon is VBC. So, we have VU or the 350, pwede natin gamitin yon. So, 350 is to 3.5. Tama? Tama. Is equal to, yung shear sa point na to, VVC, that is 133.66. Ito yan, sa taas. Okay, ito. Yan. Okay? All over. So, as you can see, ito yung kinukuha nating value, x1. Pero ang sa similar triangle, ito yung kukonsider nating lengths. Tama? So, that is 3.5 minus x1. Alright. So, what is x1 now? So, pwede natin gamitin yung calculus natin. Pwedeng shift solve. Where x is, okay, ganun din sa x2. So, 2.16 na lumabas. Okay, so 2.16 meters from the face of the support. Dun magkakaroon or dun mag-i-equal yung shear natin, actual shear dun sa VBC. And then next, dun naman tayo sa x2. Same pa rin. Mag-iba lang is yung value ng shear dun sa x2. 1/2 VBC yun. So that is, wait lang, medyo, we have a mistake there. Hindi pala VC, dapat VVC ang nakalagay dito. 100.25 dapat. Okay? So, purahin lang natin ulit to. So, ulitin natin. Dapat 100.25 kasi VVC yan. So, we will have an answer of 2.4975 or 2.5. Okay, 2.5 meters from the face of the support. Okay, dito naman, for the x2, we'll have 50.125 all over 3.5 minus x2. Tingnan sagot dito, kalahati lang nito, no? 1.25. Check natin. 50.125. Tingnan kalahati lang dito. Hindi, no? Ba lumabas? So, x2 is equal to 3 meters. Okay? Okay, 3 meters pala. Hindi pala kalahati, no? So, 3 meters. Sorry. Okay? That is D, x1, and x2. Okay? So, next na tayo. We are ready to design the shear for each segment. So, unahin na natin, class, no? Dun sa critical section. Okay, sa critical section tayo. Okay, so spacing at critical section. Spacing at critical section where VU is 300. Okay, where VU is equal to 300. So, kunin na muna natin, no, yung VS. Yan. So, VS natin is VU all over reduction factor minus VC. Okay? So, that is 300. Divide po natin ng 0.75. Bawasan natin ng VC, 133.66. So, we will have 300 over 0.75 minus 133.66. We will have a value of 266.34 as your VS. Okay? So, next, as your VS, kilonewton. Okay? So, next is spacing. Yan. So, ang spacing natin is formula AV FYT D all over VS. So, ang AV natin is dalawa times yung area ng stirrup natin, that is 10 mm, times FYT, 275, and then D natin is 500. Divide natin ngayon ng VS, 266.34 multiplied by 1,000. So, what is our VS here? Or S, I should say. Ang lalabas dito is 81. Yan, 81.09. So, siyempre gusto natin whole number, nearest 10 or nearest 5. Let us say, uh, 80. 80 mm. Of course, we need to check for the uh, S-max. Okay, so to get the S-max, we need to compare our VS to the value of, we computed here, yung 1/3. Sana yun? So, 267. Okay, itong 1/3 square root of F prime C BWD. Yung VS natin is 266. Okay, which is less than our 1/3, which is 267.32. Okay, so therefore, ang S-max value natin is D over 2 or 600. So, D over 2 natin, ang D natin is 500. So, that is 250. So, ang gano'n natin, max natin is 260. Right? So, ito yung ating S-max. So, compared to S, so, pasok pa rin yung 80 mm dito. Okay? So, meaning, we're going to use the 80 mm. Okay? Maliwanag ba? Yes. Pagka lumagpas sa 250 yung S natin, okay, that's the time na yung S-max po ang gagamitin natin. Okay? So, dito, 80 talaga ang gagamitin natin. So, we're going to use a 10 mm stirrup, okay, space at 80 mm OC. Okay? So, ang tanong dito, okay, so ang tanong dito, class, ilang 10 mm, no? So, maglagay tayo ng drawing dito sa kabila. So, ilang 10 mm? So, let's say ito yung column natin, no? Then, ito yung ating beam. So, kalahati ng beam. So, gusto nating i-drawing. So, ang tanong kasi dito, as you can see, sa actual kasi, hindi lang spacing, no? Dapat alam mo kung ilan yung stirrup na ilalagay. Alright? So, dito, let's say we have here the main bar. Ito yung main bar natin, ha? And then, doon tayo sa stirrup, no? So, sa code natin, ang unang stirrup will have here wait lang, masyadong malaki. Yan. Okay, this is 50 mm from the face of the support. Yun yung unang-unang stirrup dapat. Yung unang-unang hook. 50 mm. Okay, from the face of the stirrup. Ngayon, ilang 80? Ilang 80, ilang 10 mm na space 80. Okay? So, take note, dapat yung spacing na yan is within the 300, no? Kasi yan yung nakuha. So, dapat natin lagpasan ito dito. Okay, lalagpasan natin yung 0.5. Okay, so lalagpasan natin yung 0.5. Let's say, 5. Kung 5 yun, that's 0.4. So, kulang. So, if we're going to have 7, Pwede namang 7, no? 7 times 0.8, that is 5.6, 0.08, sabi natin. Okay, 0.56, so lalagpas na tayo doon. So, pwedeng 7, or 8, no? So, dito walang definite rule kung ilan. Basta, ah, yung spacing natin always lalagpas, no? Yung total length of that spacing is lalagpas dun sa kinuha na natin ng VU. Okay, dito sa critical. Alright? Dito. So, dapat pwedeng 8, pwedeng 7. Depende na lang sa inyo. Let's say sa akin dito, sa example natin, 7 na lang. So, we'll get 7, 7. So, 1, 2, 3, 4, 5, 6, 7. Okay? So, dito, this is 7 at 80. Okay? 7 at 80. So, the total length here, makikita natin, the total length is, okay, mag-fall tayo in what length? So, 50 plus 7 na 80. So, 610. Okay? Nasa 610 na po tayo. Yan. At 610. So, balik na tayo doon. Yan. Ito na tayo. Sige. Pwede natin tanggalin na ito nandito. Ha? Para hindi kayo malito. So, dito na tayo. At spacing. Tapos na tayo dito sa critical section. No? Spacing at 0.610 mm from the face of the meter pala to. From the face of the support. Okay? Ayan. So, next thing, kunin natin yung VU dito. Okay? Kunin natin yung VU. So, by similar triangle, as dun sa nauna natin ginawa, so, ang VU natin, let's say 350 is to 3.5. Tama? Times daw, equal to, tama, equal to, VU is to, ano yung distance nun? So, 0.610 mula sa face of the support. So, that is 3.5 minus 0.61. Tama ba? So, what is our VU here? So, ang VU natin dito, 350, 3.5 is equal to VU, 3.5 minus 0.61. 289. Yan. So, 289 ang VU natin. So, 289 ang ating VU for this point. Kilonewton. So, for the VS, we will have 289 all over reduction factor, 0.75 minus VC, 133.66. So, ano yung magiging VS natin? So, 289 over 0.75 minus 133.66. We will have 251. Okay? So, 251.67. Alright? So, for S, the same pa rin yung S natin. Ang magbabago lang class is yung VS dito sa formula natin. So, ito yung S natin na equation. Ang babaguhin mo lang dito is yung VS. So, what is our S? So 85. Okay, so 85.82 mm. Okay, so say 85 mm. Okay, compared to S max, the same pa rin na 250. So we're going to use 85. So use 85 mm spacing. So ang tanong, ilang 85 mm? Okay, ilang 85 mm? So dapat halos nasa gitna na to, no? Ng zone na to. Okay, nasa gitna ng zone na to. Right? So, ang gitna nito class, as you can see, this is this is x1 2.5. So, nasa 1.25 dapat. No? 1.25. So, para maging 1.25, ilang 0.85 ang kailangan natin? Yun yung tanong. So, that is, okay, ilang 0.85? So, let's say 10. Compute natin. 0.85 times 10. 0.085 pala. 0.085 times 10. So, 0.85 plus 6.10. 0.610. 1.46. Okay, dun magpas na. So, pwedeng 10, ano? 10.85. So, lagay tayo ng 10.85. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ito, 10 at 85. Alright? 10 at 85. So, next tayo. Class is dun sa section na yon. Itong length na to. So, ang length na yan, ang x na kukuha na natin is spacing at. So, ang gagawin natin, 0.610, add lang natin yung value ng yung length nito. Itong dinagdag natin. So, 0.610 plus 10 na 85 mm. So, 0.085, 10. So, that is 1.46. So, spacing at 1.46 mm. Meter. Yan. Kukunin natin yan. So, let's solve the VU. Diyan, sa point na yan. So, VU or 350 is to 3.5 is equal to VU is to 3.5 minus 1.46. You will have your VU is equal to 511. Wait lang. 204 pala. 204. So, 204 kilo Newton. For your VU, 204 kilonewton. Next, VS. So, ang VS natin is 204 all over 0.75 minus 133.66. So, what is VS? This is equal to 138.34. Okay? And then for our S, okay, the same formula. That is AV 2 times pi over 4 times 10 squared times 275 times 500 all over VS, which is 138.34 times 1,000. Okay? So that is 2 times. So 156 na to. 156.125. So say 150 mm. Okay? So ang tanong dito, ilang 150 mm? Okay, ilang 150 mm? Yung ilalagay natin. So take note, ito yung shear diagram natin. So shear diagram, so from here to here, we have a length of x1, x2. Ito natin yung VU at critical section. So itong length na to is 2.5 tapos 3, no? So 2.5 tapos 3. Okay, so this is 2.5 as our x1 tapos 3 ito. So kung gusto natin, so ito is 1.46 na. So magdadagdag tayo ng spacing na 150. So gusto natin abutin yung 2.5 dito. Okay, gets? So ilan pa natitira ba? So if that is 1.46 minus 2.5, so meron pang 1 meter. So ilang 1 meter ilang 150 ang kasi sa 1 meter? So 6. So sabi natin maglalagay tayo ng kahit 7. Yan. Maglalagay tayo ng 7. So 7. So 1, 2, 3, 4, 5, 6, 7. Right? So that is 7 at 150 mm. Okay, so ilan yung total niya? So total length nito is 1.05. Ito 1.05 ang total length. Okay, ito naman is 0.85 ang total length. Ito naman is 7 times 1.080, 0.56. Ang talang dito is 0.05. Yan. So, if you're going to total that, that is 0.05 plus 0.56, 0.56 plus 0.85 plus 1.05, that is 2.51. Okay, so nasa at 2.51. So, spacing at 2.51 na tayo, which is saktong-sakto na sa mismong minimum section. So, no need for us to solve for the VU here kasi nasa minimum section na po tayo. So, ang gagawin natin, we compute the spacing at the minimum section. So, that is, we have the value of, we have this AV mean all over S. Tama? Is equal to, we have two values, 0.062 square root of F prime C, PW over FYT, or meron din tayong 0.35 BW all over FYT. So, kunin na natin muna yung value nito sa baba. Ito nasa una, 0.062 times square root of 21 times 350. Divide natin ng 275. Okay, so we will have 0.362. Okay? Yun naman tayo sa kabila. 0.35 times 350 all over 275. We'll have a value of 0.445. Okay, sabi nung code natin, yung pinakamalaki ang kukunin natin. So, this is 0.045. Tama? Okay, so kunin natin dito. Let's solve for the S. So AV mean over S is equal to 0.445. So S po ang kinukuha natin dito. So we will have AV mean. Anong value ng AV mean natin? So take note, all throughout is hindi magbabago yung AV natin all throughout the beam. Okay? Which is dalawang legs ng 10 mm. Tama? All over 0.445. So what is our S here? So we'll have 352.99. Okay, let's say 350 mm is our minimum spacing. Ngayon, okay, gaya ng unang example, we need to compare it to our S-max. So, ang S-max natin dito is yung 250. Diba? S-max is 250 mm. Yung sinolve natin kanina. Yan. So, dito, siyempre, mas maliit yung 250. So, mag-prevail yung 250 mm as our spacing. So, use a 250 mm spacing. Okay, kuha ba? Yes. Yes. So, dito na sa figure natin, as you can see, okay, so nandito na to, no? Dito, sa part na to. Nandito na tayo sa part na yan. As you can see, sa actual design kasi, okay, hindi na tayo pagkadating na sa X-max, no? If your spacing is S-max na, nasa maximum na, okay? So, yung naiiba pang, yung natitirang length na ginagawa natin is, okay, doon natin ilalagay yung 250 mm spacing. All throughout this uh, left na or natitira pang length of our beam. Okay? Or yung from the center line. Ito. Center line. Okay? So, from this point, okay, up to the center line, let's say this is the center line or the midpoint of the beam. Okay, let's say the rest, okay, yung natitira pa is spaced at 250 mm. Okay, nakuha ba? Yes. Okay, so bahala na yung foreman dito, no? Bahala na yung steel man. Okay, so pagdating dito sa 7 at 150, so siya nang bahala kung ilang papasok na stirrup dito sa natitira pang 250. Okay? So 250 na yan. Ayan. So no need for us to get the exact number of stirrup na mag-space sa 250. Okay? Basta ito lang yung kailangan natin, no? 7 na 80 and then 10 na 85 and then 7 na 150. So yun lang class. This is how will you design or how uh, to design our beam in shear. Okay, so of course, this is the left portion. Like I say, this is symmetric beam. So, kung ano yung tsura dito sa left, dun sa right. So, this is one of your requirement. So, sana makakita ko ng ganitong drawing, no? Sa requirement nyo, no? Yung spacing of your stirrups. Okay? So, yun lang. Have a nice day. Thank you very much.